Good evening, everyone, and good evening to all those who have joined us online and offline. My name is Yash Madhwal. I am a research scientist at Skolkovo Institute of Science and Technology, also known as Skoltech. Yes, this seminar is going to be in English language, even though I can speak and understand Russian, but I think for business purpose, like this seminar, it will be more convenient for and more clear if I speak in English. So I'm quite long in Russia, so I'll do my best in sense to have this practice of speaking in such a way that even non-English speakers can understand me quite very well. So yes, saying that. So thank you for coming again, and thank you for joining this seminar on blockchain scientific seminar. Today's topic, we will be speaking on supply chain motivated tasks for blockchain. I'm a research scientist in Skoltech, and I have my research work mainly focusing on the supply chain area and how to integrate the supply chain with the blockchain. So yes, we can move. So when blockchain met supply chain, so as we all know, like in 2008, the emergence of blockchain actually came into picture. But by 2010, the early exploration and the initial pilots project started to appear. The main idea for blockchain, as we all know, was to have this digital assets transferability, ownership, and all. So this concept was kind of implemented or put into idea beyond finance, more into like supply chain area. So by 2011, the Ethereum white paper, when it came, so it gave us the idea of smart contracts. And since the smart contract idea emerged into the picture, many projects also started coming out where it actually implemented the blockchain use case ideas into, with the help of smart contract, into reality. So at present, there are many researches that are actually going on, and also some pilot projects have also started to take into existence. So overall, what is the problem that we have seen towards the supply chain management is that there is definitely a big problem in actually tracking the product. Sometimes when you try to procure a product, you actually don't know what is the origin, even though you assume that origin sometimes of a product is very important, that you are clearly knowing that what you actually seek is actually coming from a genuine factory or genuine city or like source, whatever. And this kind of problem, when it happens, when you have an issue of transparency, like yes, supply chain is not clear, like from where it actually came into origin. So why this, even the supply chain is big, so the issue of transparency and henceforth the origin is actually a problem. Because of this situation, there are a lot of corrupt practices that takes into picture. Corrupt practices not only means in terms of finance, but also beyond finance, like safety standards. For example, if there is a product that has to be within the safety standards by processing, if some product has to be brought or moved under certain conditions where it can be hazardous while moving. So just to avoid extra spending, there are times when it is overlooked and which can be hazardous and can be dangerous to life. So second type of corruption that can exist is the use of counterfeited products. Counterfeited means like use of fake products in the circulation of the market. Circulation in the market. Yes, it is a big problem of having counterfeited products that is going around, because people here again are feeling that they are actually buying or purchasing original product as per the real price, but in reality they are actually having the fake product that has been given to them. Because of these two things, the main issue that people also see is a cost to the company. That means if somebody finds out that yes, these things are not actually in reality like the real product that they were seeking, so it is quite expensive, not only from the buyer's perspective, but yes, also to the whole cost of the company, because sometimes even the small player within the company are circulating fake products in the big name. So this is a problem. And also if somebody makes a human error, that is yes, again, quite costly to the company. Last but not least, the information loading, meaning that time to process the information is also a problem. That means the information that you're loading and actual movement of the product that is taking place if they are not matching, it's also a product. Fortunately, all these problems that we have mentioned can be somewhat potentially be solved using the blockchain. So yes, if we implement blockchain, we can easily track and trace the product. Because of this, we will actually have a controlled supply chain of product. And once we have the controlled supply chain of products, we will actually be able to track down to the origin. And also the information is available across the full platform, in sense that the what all processes it went through, at what temperature was it made, for example, and so on. So up you can see a very simple supply chain diagram that I've included, like from the raw material to the end consumer, how the process and different stages is actually goes to reach from raw material to reach consumer from the raw material origin. Okay, so basic idea of blockchain development of supply chain is as follows. We are assuming that there are two manufacturers, which is manufacturer one and manufacturer two. And then there is a showroom, which has a final product. In between the manufacturers and the showroom, there is somebody known as assembler who is actually going to take these two products and join it, right? In the black figure, there are the trucks. In sense, there are like the transport vehicles who are actually going to do the logistical part of moving products from manufacturer to the assembler, and where it will be assembled, and further the trucks will take to the showroom. So this is a simple supply chain, how it's working. Now, integrating the blockchain, you can see in this diagram that I have marked 1, 2, 3 like number of steps, how the information flow is taking place. So we assume that the manufacturer 1 and manufacturer 2 are producing items 1 and 2 respectively, which is further loaded in the blockchain. And then assembler sees that these products have been loaded on the blockchain. After that, he's able to make a new product and further, with the help of truck, send it to the showroom. So all this process that has been mentioned over here is written and recorded on the blockchains for the easy traceability and trackability. So in industry currently, there are 5 main players who are actually working on this field. They have been starting this project since 2017, but I am not aware as of now they have completed or not. But yes, these are the big markets in the supply chain industry, including the British Airways. Right. So in short, what type of supply chain type they have is the linear supply chain, which means like it's a straight linear, like where one product starting from raw material to the end customer is moving along the supply chain, and there is no conversion or this deconversion of some item that takes place. So it is just a linear supply chain when one product reaches to the final product without going any conversion and all. So out of this, we can say there are 2 main types of supply chain, which is a linear, which is the figure on the top, and second one being other type of supply chain, like a multi-layered, multi-entities supply chain, where one product is getting distributed and dispersed equally, we can say, or like depending on the use case. So linear supply chain, where the one product starts from origin to the end customer, and distributive supply chain, where we say that one product can go to different distributive channels to the end consumer. Here in the distributive case, we have multiple end users, and in linear, we usually have one end user. Well, it all depends on the use case that you actually get, that you can actually implement using the blockchain. So what is the use case overall of using blockchain and supply chain? So one of the use cases we can see is to track down to provenance and to track down to the origin. This was a first project. There was a project which implemented like tracking the tuna fishes from sea to your plate. That is one of the use cases that you can have. You can have also counterfeit prevention of counterfeited products in the circulation, meaning that there is a genuine circulation of the product that is there. As said, implementing blockchain can definitely reduce the cost of the company and also increase the efficiency. And certified sourcing, meaning that you can actually provide the certification of some product that is originating from some origin. And for sure, even though that data sharing is vital, are also somewhere a very confidential part, in sense like companies are not willing to share data, but some cases the data has to be shared depending on the use case. So this is what some simple use cases can be used when you implement supply chain and blockchain. So we start with idea of using tokenization in the supply chain. So why do we need tokenization in the supply chain? With the help of tokenization, you can actually make an asset representation, meaning that if you have one token and one item, you can actually associate that this physical product can actually be digitally represented in a digital form. If you have this tokenized representation digitally, you can for sure, again, go for track traceability to see the origin and see the provenance from where it came from. And also a fractional ownership can come into picture. What is fractional ownership? That if a two token products are forming to become a third one, so the third product is actually consisting of two parts, and this is kind of ownership of the product that was actually used in the supply chain when the conversion actually took place. I think in next coming slides, we will see some type of examples. And last but not the least, if you have this tokenization, you are actually giving an idea of digital twinning, like actual digital representation of some physical product. So there are like three main types of asset tokenization as per our research. So first is the linear ownership transfer, and second is the token conversion, and third, the token dismantling. So if you talk about linear ownership transfer, so assuming there is a first guy on your left, so at transaction one or like timestamp one, he had a product which is simply transferred to the next one. And then later on, he transferred to the third guy at time two and the fourth guy at time three and so on. So this is a linear ownership transfer where one product is just simply being transferred from one point to other point, which is quite as equivalent to say, let's say in blockchain, like if we talk about Bitcoin, you have one Bitcoin, for example, and you are owning at some time, then you later transfer to the next person and so on. So this is what a single linear ownership transfer can be represented as. Next, we talk about the token conversion, where on the top of this tree, if you see the final product for like part 1, 2, 3, 4 is consisting of parts 1 and 2, parts 3 and 4, and further if you go down the chain, you can see that the part is actually consisting of part 1, 2, 3, 4, like if you see the left side of the image. We took a very simple example of on the right side where you can see a supply chain of aircraft turbine. I claim that this is not the actual supply chain example, but this is just an understanding that how multi-tier supply chain of aircraft turbine can actually look like. So to have a final turbine, for example, if you take the picture on the right side, you can see that it goes through a multi-level, multi-tier supply chain, and each and every product, if we assume, is tokenized and converted and so on to make a final product, it has to actually go some process. So this process can be looked like this thing. So we take a very conceptual idea over here that there is a company Z, which is making a part number 3. So this part number 3 usually consists of two parts, parts 1 and 2, where we assume that part 1 is made by company X and part 2 is made by company Y. Now, in order to make the part 3, which is made by company Z, the part 1 and part 2 should be genuine, meaning not in terms of product, but assuming that the transfer of part 1 from company X to company Z was correct, there was no problem, everything was certified and so on. And similarly should be for company Y, where it transfers part number 2 to company Z. So assuming if we take the first situation where part 1 and part 2, which is made by company X and Y respectively, the company X transfers part 1 to company Z, and this transfer is actually noted in the blockchain like this. So you can see on the right side, the transaction is indicated by transaction 1, where company X has removed the P1 token, if we are assuming the part 1 token from its company base, and sent, like company Z has plus of P1 token as an output. So this transaction is recorded in the blockchain. Similarly, if we take the same situation for part number 2, the part number 2, when it is transferred from company Y to company Z, the same transaction when it was, or the same action when it was moved is recorded as a transaction 2 in the blockchain, which says that company Y's part two token has been removed if we are representing in the token form, which is equivalent to the company Z actually receiving it. Now, when company Z is making the part 3, it needs to see the blockchain and verify that this two transaction actually has taken place. If this two transaction has not taken place, this will technically be not correct, in sense like there can be an error depending on the smart contract if you have implemented over there. So how it will look, so while making part 3 at company Z, so a transaction 3 will be generated where it says that part 1 from company Z is actually there, linking to the transaction 1, and part 2 from company Z is also there, linking to the transaction 2. Based on these two transactions, if they are correct, it can be merged and it gives an output of a part 3, which is P1 plus P2 for the company Z. So this is a very basic and conceptual idea of how this tokenization merging can take place. And this conceptual idea was actually implemented in a smart contract that we in some research work that we had done. So what was the idea over here? Here we took a concept of a token standard of ERC-115. ERC-115, for those who don't know, I think, yeah, here. So ERC-115 is a type of Ethereum standard, which gives you a combination of ERC-20 and ERC-721. They are stored in index form. That means like each ERC is indexed, and like what type of ERC your ERC-1155 will be having inside, they are stored in the index number. So coming back to our workflow, that if you can see on the right, we have exactly taken a similar situation where we are going to transfer part 1, part 2 to company Z, which will be making a part 3. So how did we implement this situation? We took the following methodology. We have 3 companies, like said, company X, Y, and Z, and on the right side, you can see their addresses and followed by the smart contract that they have deployed individually. And when each of the company deployed a smart contract, this on the down, you can see, on the down, you can see that they have deployment also, the smart contract at where it was deployed. Okay. After this thing, company X creates a token with this token ID, with token ID 54DFC, and similarly, the company Y also creates a second part, which is token with token ID 6132EVAL, for reference. And these two actions, if you see, are recorded in the blockchain of their creation. Fine. Moving on, right, when the transfer takes place, that means first there is an internal transfer happening. So on the figure on the right, you can see a green box. The reason of indicating the green box is like kind of, not exactly a virtual zone, but kind of a virtual, well, kind of an area where the internal transfer is actually taking place. So the X and Y company, they have internally transferred within the smart contracts limit. They have made a 2 transaction, you can see, of creating a token, which has some metadata that this type of token is only accessible or like sent to the company Z. So what will company Z do? Company Z will see the blockchain that the actions of creating token part 1 and part 2 actually took place. That is only when it will be able to replicate the part 1 and part 2 within its smart contract. And if this, after doing this, it will be easily able to converge into a new form of token. How did we do this part? This, we have taken the features of ERC-1155, where you can actually, which gives you kind of a token conversion, which you can represent on the blockchain. So this was a simple workflow which we implemented to show how the token can be converged using ERC-1155. We added one more feature to this situation, which is talking about the token dismantling. Now, what does token dismantling mean? So assuming till now we have been talking from down to up approach, where you had like part 1 and 2, which makes part 3. What if there is part 1 that can further be made into part 2 and 3? So this thing can also be done, and this area actually has very less number of research to be done and less number of existing work, if I'm not wrong. Yeah, so a very simple structure is like this. So component 1 and component 2 makes a component 3. At some time, that product 1 can be further split into another different part, like 3 and 4. So not necessarily to be split back into 1 and 2, but rather let's say 3 and 4. A simple example, I think I will show you towards the end of this part of this topic. I'll show you one example, like where this 3 situations which I told you can actually come into picture. Okay. Yeah, so this is a very simple example that we took, which combines all the 3 parts of linear supply chain, conversion of supply chain, and splitting. This is a simple example of aerosol respirator. So you can see that to make this aerosol, mask, you have different components and different manufacturers who are working in different areas. So the green boxes are kind of different companies, let's say, and internally of each green boxes, there is an internal transaction that can actually take place. So you have in the first company, the plastic pellets, which makes the body of the respirator, and then it just makes the structure of the gas mask. Followed by the company on the smart contract for the filter manufacture, you have gas mask materials that it already has. It can make gas mask filter and send where there it is converting to the first company, and followed by the next step. So this is, in short, a full process of how the supply chain of anti-aerosol manufacture can actually look like. And here internally somewhere you can see, yeah, at at the gas mask respirator, it has 2 outgoing arrows, which means here the product is actually getting dismantled. One thing that we should always make sure and take care at this point is that it is actually following a directed acyclic graph, that there is no cycles into the picture. This research was done assuming that each and every supply chain is a directed acyclic graph, like it moves from one point in unified direction to the other. But that does not stop us from coming up with new topic or new research direction of what to do if there is a cyclic supply chain. Well, cyclic supply chain do exist, it exists, but that is sometime beyond research for future, but not for now. Okay, so coming back to token dismantling, this is how a simple concept we took into picture. So we have a part 3, which we know was made from part 1 and part 2. Well, in this case, assuming we don't know that part 3 was actually made from part 1 and part 2, but let's take an example of a ore that comes from earth, and this ore can be further made into different metals and all. Well, I'm not from that background. So assuming that you have a mineral that you have taken from earth, and then you can make other, minerals from it, let's assume. So yes, the example over here is that the part 3 has to be split into part 1 and part 2. So how do we do this thing? We take a very simple idea that to make the part 3, we do make, but at the same time, we take the contract address at the smart contract it was deployed, and further hash the address such that we can actually track back that the token address, which was XOR of a contract address and the hash of all the addresses it wanted. The hash of all the addresses meaning over here, the part 1 and part 2. So for example, if you have product being split into 2, so you will have the array of 2 addresses, which is part 1 and part 2. But if you have more, so you can increase as it is. So this all calculation is usually done from the blockchain, and in sense the smart contract that is deployed on the blockchain, and based on this idea you can actually give a simple example of how you can actually dismantle something. Okay, this idea structure which we showed you is, well, it does look a little complicated. So we came up after some time a very simple architecture of a more complicated product, more complicated scenario. So in this scenario, we tokenize the hydrogen fuel generation, in sense like there is a renewable sources like water, electricity, etc. They have an internal process of how you can convert this thing with the process of electrolysis, that you're able to generate some hydrogen fuel. Yeah. And based on this hydrogen fuel that is generated, you can simply easily transfer to the, how it is called, the gas stations, assuming hydrogen fuel stations, which will further be filling the vehicles like truck, bus, etc., and so on. So this fuel method can be actually implemented on smart contract, and again with the help of ERC 1155, but in much easier way. So if in this figure you see, there are two types of flow that is happening. Number one is physical flow. That means a physical product like, let's say, some liters of water, some electricity, assuming it's physically moving from point A to point B. And also in parallel, the same information is being transferred from one point to other. But here you can see that the information transfer is comparatively faster than the physical transfer, to which also we will address this problem little later. Okay. Right. So in this example, we have taken hydrogen fuel generation. So to make 1 kg of hydrogen, it is a standard requirement that you should have 10.9106 liters along with the 55 kilowatts of electricity. So if you provide this much minimum amount of this much of water and minimum amount of this much of electricity, then and only then the electrolysis plant will be able to convert the 1 kg of fuel. And 1 kg of fuel, I think you need some, there is also some already calculations that how many kg of fuel and etc. is required to fill car, truck, etc. We'll come to that little later. Okay, so the actors in this scenario are the water grid. Water grid can be your water reservoir or dams, etc. And then you have electrical grids. Electrical grids like, for example, again, dam, which is producing electricity, or windmill plants or solar, etc. And then you have electrolysis plant, who is actually going to convert all this resources that is got into fuel. And then you have fuel station, which will actually be filling fuels to the vehicles like car, buses, and truck. Okay. So this is the very big overview. So you have 3 phases. One is the production phase, distribution phase, and delivery phase. Production phase, as it says, that here the production of actually the fuel will be happening. You can see that there are 2 different sources of renewables, like electricity and water, which at the production phase is meeting the electrolysis plant, then further transferring to distribution center via distributing using the truck, and the final delivery where it is actually filling into the car. And all this process, each and every process of all the action that you can see on the screen is actually being recorded in the blockchain and effectively have been implemented. So if you remember smart contract, ERC 1155 in the previous case, there were lots of smart contract being deployed every time, which can be very expensive in our situation. But over here, we are just deploying only one smart contract and one smart contract per supply chain, which is comparatively much effective and efficient to do it. So here we are having, here we are having only one ERC 1155 smart contract where we have indexed water, renewable, and hydrogen to index ID 0, 1, and 2. And we have already implemented this requirements in the smart contract that water is 10.9106 liters and electricity is 55, 55 and 4 zeros amount of electricity is required. If you see that we don't have any dot, like if you see in the previous slide, I had mentioned requirement is 10.9 and so on, and electricity is 55.0. The only reason we don't see a dot over here is because since we are talking about smart contracts specifically for the Ethereum network, it does not allow us to have float. But in order to not to have float, what you can do, you can actually have multiples. So we have decided to take a decimal value of, I think, decimal value of 10 to the power 4, I would say. Yeah, 10 to the power 4. So that is where you see a big number, but how you can solve this thing? You can solve this thing by using a front end. Like when you have an application, there you can have a filter that every representation of numbers can actually be divided by 10, or not 10, 10 to the power 4 and shown in front of you. So when you will, when you expand this application, you can actually see that on the front end, it will be 10 point something and so on. So, okay, next we talk about access control. Our smart contract is implemented in such a way that you can actually control like who is responsible for doing what. For example, Ethereum blockchain, it's a public permissionless network, but smart contracts help us to make it accessible, help us to make it little better in access control, meaning that even if your architecture says that water generation should only be done by water reservoir, that does not mean that electricity can do it. So that is where we have made a good access control, such that only the responsible entities on the screen, for example, can do it. Like, for example, energy can only be produced by energy sources, hydrogen can only be produced by fuel, and so on. Formula for creating maximum amount of hydrogen production is over here. So what we have taken on the smart contract, the hydrogen production is actually being produced by checking the minimum of maximum amount of water and maximum amount of energy. And further on, it checks how do you get the maximum amount and how do you get the maximum energy and so on. So whenever you're making a amount of hydrogen, it checks your balance, that do you have enough amount of required resources or not. If yes, you have, it will produce for you the maximum possible hydrogen. If not, it will show an error as per our architecture. So this is a very long algorithm of fuel production. So I think towards the end of the slide, we have presented with the paper, like references of the paper. So probably you can go and check there more in details how this algorithm actually works as. So as per the consumption per fleet, like our team members, they had given this data information that approximately on the daily basis, there are approximately 3,000 Nexos, that means car, who require single amount, approximately 6 buses. There are 200 buses, require 23 units each. There are 45 trucks, which requires 50 units each, and so on. So based on these daily requirements, we have calculated and summed up the total requirement that is required to fill this thing. And based on this total requirement, we have simulated by taking by hypothetically taking 3,000 cars, 200 buses, and 45 trucks. We literally did not do it physically. Fortunately, blockchain frameworks like Hard Hat framework, they give you this testing environment where you can actually do a lot of multiple things, such that you can actually simulate a virtual environment and do the calculation of what you require. So you don't have to deploy and literally do the field work, but rather in your computer, you can actually deploy a local node and do all the activities that you require. Okay. So yes, so how did we run the experiment? We first for sure run the node. We deployed the smart contract and we used Python notebook to run the simulation and record the data. So what are some steps which were happening? So there was water provider, which was minting water. That means it was making water. There was renewable provider, which was making energy. Then there was water provider who was transferring the fuel, transferring water to the fuel generator. And similarly, the renewable provider was transferring energy to the fuel generator. Assuming that the fuel generator had enough amount of water and resources, it was able to create fuel. Fuel generator burns the amount, meaning that whenever you are sending the physical fuel to a car, there has to be a way that you are actually destroying the tokens. So we came up with the idea that we will be burning these tokens into some, I think, address 0, if I remember correctly. That is what we are doing. Okay. Then the base or requirements on the smart contract, by the smart contract, the fulfilling with the help of filling station is actually happening. Okay, so based on this workflow, this is the result what we achieved. So you can see that different role which was carried out by different people, I mean different actors in the situation, in the scenario, I would say, and amount of gas that was used to do such actions was recorded and noted. So based on this thing, we came up with this formula, like how many days and how many size of the fleet, you can actually check that how much gas will be consumed in this in your scenario. So based on the daily requirement on this slide, we can say that approximately 13 Ethereum blocks it will take for you to process, which is somewhat equal to like 2.5, 2 minutes 36 seconds of the network time. And I think this is the information that we have taken like an average network time, if I'm not mistaken. So in short, we can say that this type of architecture that we have for the fuel generation is quite feasible for like a simple private blockchain-based solution. Yeah. So the problem that we see in this two scenario is that there is a physical flow and then there is a digital flow. So digital flow is much faster than the physical flow, which is great in one hand, but also a problem. Why it is a problem? Like it is a problem because when you are actually making a physical movement of the product, there can be a problem with deliveries. So, and if you have delivery problem, it is very difficult to see who was actually accountable for some problem. Let's say a package gets stolen. Who will you blame? The seller, receiver, or the transport guy? You don't know. The product is damaged. Again, it is a problem situation. And sometimes also you make the wrong delivery. But on the blockchain, you can actually note that the delivery was made to right person, but in reality, the product actually went to somebody else. So these are some problems that can happen. So because of this thing, we do need something for proof of delivery, that you're proving that your product was actually received. So what is happening? Behind the scene, we have taken a very simple linear supply chain. Example, a jam company who is making jams from apple to shop, for example. Like, there is a farm, there's a transporter, there is a jam factory, and then there is a shop. So yeah, this is a very simple supply chain we have taken. So the visual flow workflow looks like this. There are like data structures, not exactly data structure, like data tables of individual companies there, and based on the actions, they are being recorded. So you have a farm who records an inventory, then it records into transport products, and further it sends to the next one, and so on. It goes to the transport, to the final company, and it finally sells. It happens. Same implementation over here for the two sources. For example, if you want sweet jam in this case, let's say apple plus sugar. So one source is, let's say honey, more healthy. So there is farmer who is making apples, and second is bee farmer who controls the sweetness of the product. So this is a simple supply chain of how the things can move. And I forgot to make an arrow to the shop. Okay. So the proof of delivery comes into picture a little later, but how the idea is working over here. So each and every company entity is having an incoming assignment and a structure of information that is actually controlling its movement. So for example, you produce an item, you can see you're producing apple of 50 units, and there is a transporter in between where you can actually load this first consignment to the transporter and send it to the receiver. On the receiver's part, it can see there was a current transporter who will be receiving the incoming consignment like this. So incoming consignment is actually received, assuming that everything is working fine in this situation. So in this situation, we have actually split it not exactly between seller and buyer, but also between the including transporter in the picture. Like there are three intermediaries, not only sender, buyer, but also transporter. The sender takes the product, gives to transporter, transporter sends to the buyer. But this is again quite expensive in terms like there are three entities involved, and which means more actions will be required in the picture. That means more number of money is involved. How can we solve the problem of direct between sender and buyer, including the transporter? So this is where a proof of delivery concept gets more into detail. Here you need to kind of prove that the consignment is delivered, and if there is something wrong with the consignment, there is a mechanism to resolve this type of dispute between the sender and the buyer using the concept of multi-signature. And based on this, for each consignment that you're transferring and sending, you can actually also measure the performance of the scenario. So how it works. So for example, I am a buyer and I deploy a contract for my sender. So contract for my sender has some time limit. Let's say, 10 seconds. 10 seconds is the minimum time and maximum time is 110 seconds. We'll talk about seconds. In reality, it's like more in details. We are making sure that during the first 0 to 10 seconds, it is able to accept the consignment. So, well, delta T is the, how to say, 10 seconds time frame we have taken. So at 0 to 10 seconds, the consignment was accepted. Yeah, the consignment was accepted, which says that at the estimated time of arrival at some time, this product, if it reached during some time frame, it is correct. Otherwise, it's not accepted. Okay. So, right. So buyer does all this action usually for the sender, so that sender has an opportunity to claim that yes, it can actually do some actions, or it cannot do some actions or not. Because if seller cannot meet some demands of the buyer, it can actually reject, and there is nothing wrong in doing that. Okay, so in the end, if it accepts, it will provide with the estimated time of arrival, that at for sure what time it can actually do it. Okay, so after each delivery, when the delivery is actually made, the receiver checks, was it actually made during the promised time? If yes, it's fine, he can actually reject, he can accept. And if there is some problem, they can also mark it dispute. Dispute means where seller and buyer both claims that both are right, but there has to be some mechanism to say either one, which one was right. Okay, this type of resolving a dispute is happening off chain, meaning that for some reason, like this type of how to say, agreement between seller and buyer is best achieved if it is happening in person. Let's say like both are agreeing at some time. So if both of them agreed, they need to make a signature online, like blockchain based signature, like multi-signature, and also this dispute is resolved. Otherwise, this consignment is considered as a failed consignment. So closing an order can be checked like number of transactions, which was equal to should always be equal to number of successful deliveries and failed deliveries, including the dispute. So in the end, dispute will not be left as dispute. Dispute will be solved at some point or the other. So this is the same workflow which we have just mentioned of how things work. And yeah, so moving more into deep inside, the each and every consignment follows this algorithm to check if it is fine or not. So an experiment can be look like this. We have taken 20 products with some time slot at what time it should be done and all, and what time did they order and what time the product should be reached. This was the making order. So when it comes to receiving order, you can see that there are some false accepting. What does false accepting means? With the help of Python, we have randomly chosen few like four orders which was marked as false. That means they don't accept the order. But you can see the order number 19 over here is marked true, meaning that it was accepted but marked as a dispute. Now we take this order number 19 and all the failed orders, and we can say that total number of n, that means total order is 20, which is summation of success order S, false, not false, fail order 4, and dispute 1. So flag continue is like, is the order still continuing? That is something else. So how do we solve the dispute? So off chain, they agree that should it be solved or not. So if they decide to, let's say we are assuming here that they have accepted the success of the product. So they have on-chain signed signature 1 and signature 2, and also a dispute resolved signature that was made. So in the end, if everything was fine, they accepted the order, and we can see the final dispute is 0. So you can see over here, when you're accepting and sell something, you can see a dispute was resolved. There can be a better way to resolve a dispute is by integrating the IoT devices to the supply chain. What is the basic idea of implementing of IoT devices to the supply chain? Like initially, what used to happen, there was a device which tells an actor, hey, example, the temperature right now is 10 degrees. The actor actually goes to the wallet and puts this information to the blockchain. But with the IoT integration, the device can actually communicate to the blockchain. Well, this does not mean that the actor and wallet are useless. No, they are useful for sure, but not in all situations. For example, When you have a truck that is going continuously and there is a refrigeration system in the truck, which wants to make sure that the temperature is well maintained, etc., for sure, that is a usual scenario. There you don't need an actor. But having an actor in that situation can be, how to say, useless, I would say. Right. So with IoT integration, we can say that we have a system which is a device, let's say, which is integrated to the truck, which continuously communicate with the blockchain and keeping the system updated as the truck moves on. Okay, so in our proposed device, our device consists of two parts. One is Arduino and second is Raspberry Pi. Yeah. So what does Arduino do? Arduino is like a small IoT device, I would say, that continuously communicates with our Raspberry Pi, to which Raspberry Pi further communicates with the blockchain, like in this diagram over here. So sensors are connected to the Arduino with some inputs like sensors, outputs like LED and Raspberry Pi. There can be question, and well, there it's a common question: why not directly connect sensors to the Raspberry Pi? Because this is possible, but as per my experience, Raspberry Pi has only digital inputs and output, but Arduino Uno gives you an analog input through which you can actually have a range of inputs that you seek for. So for example, we use potentiometer. Why? Why not temperature sensor? Why not something else? The reason to use potentiometer is that you can actually physically control the input. Just for the reference, we are using potentiometer. In reality, you can actually use anything, because controlling a temperature is more difficult, like you need to change the environment and all. But with potentiometer, you can actually do physical rotation of the device so that you can seek and experiment with the inputs that you want. Okay, so yes, we integrated Arduino and Raspberry Pi in such a way that Arduino is sending information to Raspberry Pi, and Raspberry Pi is authenticated with some private keys, meaning that the private key is loaded in the device itself, and the Web3 library is also loaded, so that Raspberry Pi is directly making a transaction and communicating into the blockchain. It is somewhat doing some technical aspect what the other wallet usually help you to do. So this is how the device looked. You can see the first part on the left is like the breadboard, where the input like potentiometer, including 3 LED lights. Like if it is red, like just a simple use case. If it is red, that means it is danger zone. Yellow is like warning zone. Green is like you're perfect, and so on, which is connected to Arduino Uno and further sending the communication to the Raspberry Pi. Well, as per this picture, it looks directly going to Raspberry Pi, but that's not the case. Okay. Right, so this was a very simple use case we took. We took that in our smart contract. We have deployed a smart contract on the blockchain network, which monitors the temperature of the fridge at some time. And we have taken interval, I think, of 20 seconds, if I'm not mistaken. We will check. We have taken interval of 20 seconds, and it records the maximum amount that it reached during this time frame. So this logic was implemented by Python, but whatever information was the maximum was just being recorded temporarily, and it was being sent. So here you can see an output. Sorry for the graphics if not visible clearly. This was a deployed contract on the, I think, Binance network. And you can see that if you go down, you can see the product initial dispatch. At this time, the product was done. In the center part, you can see approximately, I think, yes, I think it's 20 seconds where each and every transaction is being done on the blockchain. The timeline is already high. That's why you have it in days. But if it's fresh thing, then you will see in seconds, actually. And when the product is received, you can see that the first 4 transaction is incorrect transaction. That means it is giving you an error of thing that is moving. Okay, so this was implemented and deployed for the testing purposes, and yeah, so it was working with a direct communication with the blockchain. Okay, so to have a very simple use case, we took an idea of like a cheese which moves from New York to California. And there is a route which actually goes from New York to California. We took all the information from the internet, like what is the temperature, yeah, what is the temperature, how much time it takes, etc., and etc. And also we took another information that how many cheese producing company are actually there in New York and what type of businesses they have been opening and closing and so on. Using these two scenario, we have some results in front of you where we actually show that to granting access in sense like how many businesses being set up, how many businesses are being closed, taking this information and also to produce and track and to receive products. This simulation was done. And you can say that since it was a long simulation, that there are some fixed time was kept. We, with the help of hard hat framework, simulated the blockchain by time stamping, I think by days, if I'm not mistaken. So every 24 hours we recorded, and you can see that is the only reason the action track, which is executed by a transport company, not a company, a transport car, has the maximum amount of gas that is used in the scenario. Right. So to implement this full process, like so how to implement supply chain and blockchain together, I would say like first you identify the use case and you define the objectives, like what objectives should be met. Based on this thing, you design the architecture, and after that only you have a smart contract that you can develop. You test the smart contract, you deploy first smart contract to the testnet, and if required, you develop the application, the front end, and so on, and further launch the application with the real deployment on the main chain. Okay. All this point, like even though you have usually IoT working and all, so but there are some cases where you actually need to read the information from the blockchain, information generally from the product. So this was a old experiment done just to show you which is the best device to read the QR codes. For example, there are two surfaces, which is flat and curved. So with this table that you have, you can actually make simple labels on the products to read the information. But what problem do we see over here? And like, or what the overall problem that we see, that this label is just like a simple sticker. So you can actually take this sticker, you can put it and say, hey, this product is real. But somebody can actually take the sticker from the real product and put on the fake one. That is a problem. So how that problem can be solved is like a question of future research, which actually lies is by introducing the concept of digital twinning. With this digital twinning, you can actually have a digital twin certificates like kind of NFTs in the picture, which you can circulate on the blockchain. So this is one of the potential way which you can actually work and develop and expand your research in this direction. Okay, so all this concept that have been shown to you, these are the references, these are the published paper by us. Right, so we will be sharing, right, Yuri, the presentation with the everyone, and they can have a look into it. So thank you for joining this session, and these are my contact. You can scan, save my information, my GitHub, my ResearchGate, and my Telegram information is there. Thank you.
Thank you for the exciting talk. Dear colleagues, do you have any questions in room or in Zoom? Yeah, we see the first question in Zoom. Well, quite a lot.
Oh, nice.
Okay, Yash, can you?
Thank you for the talk. Couple of questions. Is there a way to certifiably synchronize the information in the physical flow flows without manual work? So the
So the first question is,
okay. I'm
just for okay, for Zoom, I think everyone can see me.
Why would they do it?
But maybe flow the first question, is there a way to certifiably synchronize the information on physical flows without mutual work so that the state of blockchain remain relevant?
Yeah. So I think I will answer the first part. Yes, there is a way that you can actually synchronize. This is where we showed the concept of the proof of delivery, that you can just make sure that the delivery has been sent till it reaches to you. And once it reaches to you, that is where you can actually that is when you can actually receive the consignment and say that if you accept the consignment or not. This is somehow a way to keep a synchronization between the physical flow and the information flow. You can do it manually, but without manual can be a way to do it. Like, for example, if you see a consignment of truck that is coming, you can actually put cameras in the entrance and see that if the truck comes inside, the truck, because of some cameras, can actually communicate with the blockchain and say at this time this thing is done, so it can be accepted based on the information that it is there. Did I answer your first question? If yes, maybe.
Yes, these questions are by Anton. Anton, you are now a co-organizer, so you can unmute yourself if you wish, and maybe add some clarification questions or comment and answer. The second question, would you track each apple in a track on the blockchain? And if you would, will it be possible to track from exactly which apples a pie is made? That is, apples go to a large tank to make jam for the pie.
Well, answering your specific this question, I can say yes. And why do I say yes? Because it all depends on the blockchain architecture that you're actually going to implement. To be honest, more the complex architecture, the more complex, well, more expensive it will be. So if you really want to make sure that from which apple tree it came from which apple jam machine it went, you can actually implement. It depends on the architecture design that you have.
Thank you. Third question, why would the two adjacent parties on the road switch to the blockchain solution from the using just common way bills that seems to provide the same grounds for contract fulfillment overall?
This is reference to which part?
Just for any, so why should parties switch to blockchain supply chain instead of standard procedures?
Oh, yeah, sure. Because I would say because of the following problems that every supply chain has, which was the introduction part of our talk. Because there is problem of tracking, like you gave an example, in your question in the second one, where you actually need to track the apples from where it came for your apple pie. Yes, and you want to make sure that it actually came from the best apple in the world. That is why you are going to make your apple pie. So yeah, that is the information why we require the blockchain in the situation.
Thank you for questions.
Thank you for your question.
Any other questions? While you are thinking, people in Zoom, you can also may raise a hand and we will unmute you and you can ask your question orally. No need to type.
You're welcome.
If you wish. Meantime, let me ask a few questions. So you mentioned that DAGs are useful, then we can see the supply chains. But what will change if our graph will have cycles?
Yeah, so this architecture will definitely not come into picture because this is a complex architecture what we had used long back, and based on the smart contract, it will throw us an error that this thing is not possible because it has already been done, something like that. So DAG's idea is like you have unified, and every time whatever some action you do, for example, you create tokens something, or you merge token, it should be a new address. But if for some reason, as per the smart contract, you're having repeated address, answering your question specifically, if we have cycles, we will get error as per the architecture. So we can definitely imply a new architecture where you have a cyclic graphs of the products, like recirculation, if to say.
So from technical point of view, it is easier to trace back things when you have DAG. Yes.
Oh yes.
And and also most of the real supply chains are
DAGs based, yes.
But with some technical modifications, probably it is possible. Am I right?
Yes, it is possible. And also there can be a way where we have a cyclic supply chain. We can have how many iterations it has already gone through. There is a way to implement to check how to track back of number of iterations back. there is something.
Thank you. Yeah, just something indication in chat.
Okay.
Also, the part there you talked about IoT device connected to the blockchain. It refers maybe some analogy with account abstraction ERC 4437, but there in account abstraction we try to provide user easy access to his assets. But in your case, you rather consider a company story. So company has, or yeah, maybe company has a lot of devices and you want to manage them all together. Do you see any analogy, maybe something from account abstraction will be useful here?
Account abstraction over here. I mean, like, can you be more information, like what exactly account abstraction over here means? Like, because
Yeah,
we have
just any ideas may be useful or not. So maybe we need well, account abstraction is for users, maybe for situation the users control many devices, let's say, are also common. Maybe we need abstraction how to control a lot of devices.
Okay, well, since it's an IoT device, so I can tell you how to control more in specific. Assuming if the device is already fixed to the vehicle, you can actually authenticate every time with a new ID over there. And these IDs are actually replaceable and changed depending on the use case. So first time you can have an ID A of the truck, and second time you can have ID B, or you can actually also remove the device and put. So this is some way to control the IDs or like devices movement around. The very simple example I could think of.
Great, thank you. Any other questions? No. Well, you mentioned several projects. They looked like real projects, but you've told no real company names. Maybe you can provide us insights for what companies some of these projects.
Yeah, sure. I would love to do that. Well, I think IoT is still ongoing, so I think I'll tell with the supply chains initiative of proof of delivery. This was done with the help of company in Italy, Ponti, who makes vinegar and olive oils, right, if I'm not mistaken. So this architecture was implemented in the supply chain. In the paper, we have a table which shows how proof of delivery in scenario of Ponti is actually working, but I have not included in the slides over here. The one with the last part, it's as you can see, this picture on the right is plastic pipes. Yeah, on online also. So it's plastic pipes. So this was implemented on the plastic pipes implementation of supply chain. What else do we have? Well, there are some more projects which are implemented and they are included in the reference over here. And in the reference, you can actually see and read more of actual implementation in the companies.
Thank you.
Thank you.
Any other questions? No, not in chat. Okay, so you mentioned hat.
Yes.
It's a popular instrument to test.
Yes.
And also to do experiments for science. But these days also instrument called Foundry becomes more popular. Have you heard about it?
Yes. Yes, I've heard about it. The only reason I have not used Foundry is because it's Rust based. So, well, I don't have experience in Rust as of now, but I also, prior to using Hardhat, I had no experience in JavaScript, but with Hardhat, I learned JavaScript on my own. So maybe if I look into Foundry, I will learn Rust also. So as of, well, for the people, for the listeners who are with background from Python, I would say Brownie is another framework, which is completely Python based, but Brownie came much later and Hardhat was already there in the picture. So I did not think of going to Python, which I already know.